out, I'll start with a few generalities about the principles underlying the prototype of a guidance tool for text production which we have been preparing, talk a little bit about the underlying representational model and the type of information presentation we intend to provide. And then the interesting part will be the demonstration given by Theo Bothma, and he will also talk a little bit about the computational architecture underlying and the procedures we have implemented. So the context is a cooperative project where we are interested, on the one hand, in designing information systems that avoid information overload on users. And when you deal with complicated lexico-grammatical phenomena, it is not trivial to avoid such overload. And so we thought of a way of presenting exactly the information you would need for certain types of tasks you want to do. The examples come from the South African Bantu language Northern Sotho, have been provided by Prinsloo, and are a case of interaction between grammatical, lexicosemantic, and other constraints. At last year's Eurolex, Michael Randell talked about the possible future of dictionaries and lexical information systems, and he said something like, it is equally plausible to imagine that the heterogeneous functions of dictionaries might be better performed by separate, more specialized resources, automatic translation tools, text remediation software, and things like that. And one example he cited was a design study which we had presented at the last ELEX conference in 2011. And as we promised a prototype implementation of that at that time, basically now the time has come to show you at least a frozen demo of that prototype. So the lexicographic principles are somehow inspired by the lexicographic function theory and the idea that different tasks need different types of guidance, and that from an information scientific point of view, you would want some generic tool component which could be plugged into an electronic dictionary and which would provide information on demand such that users can themselves determine how much data they want to be displayed. Computationally speaking, we basically aim at a generic extensible architecture which is based on web services. Coming back to the lexicographic function theory, most of you have seen work by Bergenholz and Tarp where they talk about different types of needs, most importantly for our purposes, cognitive needs where you want to learn something about words or concepts, and communicative ones, be they oriented towards text production or towards text reception. And Tarp has it that users should get the appropriate amount and types of data, enough to solve their needs, but not too much. As I said, a second element which interested us was the question of how to cater for complex issues of lexical choice, so in text production, evidently. And the basic phenomenon is that languages show different conceptual and grammatical granularity, and that for a learner of a foreign language, this complexity may result in a rather unhandy system. So examples from Northern Sotho concern, and that is what we are going to talk about, copulatives, so the translation of things like to be, I am, he is, and so on, where we have 3 different semantic subtypes, 15 noun classes, basically cross-classified, so you can imagine what kind of grammar tables will come out when you deal with that phenomenon. Other examples are the rather fine-grained subdivision of color terms or of names of relatives, so kinship terminology in Northern Sotho, but also in other languages. So lexicographically speaking, as I said, we want to provide adequate data for such complex lexicalization cases, and we want to do that with a relatively generic but situation-adapted presentation device. The underlying model is largely graph-based, and in this case, basically tree-based. So if you have a situation where you want to lexicalize a certain concept, you might have a choice between 2 options, and depending on which one you have chosen, there may be further options available. So imagine these things as having this kind of tree-like shape. What we intend to do is to address those distinctions which are relevant for the lexicalization case at hand, and support users, at least on demand, with information about each of the elements which can be chosen. So we allow for something like information boxes attached to these elements. Furthermore, we allow for information boxes at the choice points, such that the type of information you would find in the text of a grammar is available also before you have to make your choice to guide you through the different options. So this was for text production. For text reception, we think that the same structure can be used, but in that case, the idea is to highlight items in a text which you are reading and to get the path through this lexicalization system, so to say, which has led to the respective phenomenon. And with polysemous items, obviously, you would get more paths as a different analyses, if you like, are available. For cognitive purposes, when people want to learn about the system, the idea is obviously to show the full decision system, optionally with grammatical information boxes at the choice point. So in a way, this amounts to the same amount of information as you would have in a grammar table, but structured still from the viewpoint of lexicalization. I think I hand over to you now for the examples and for the demo.
Thank you, Uli. So if you are talking about a text production dictionary, you would have a standard entry in the dictionary, maybe as one of the fields, an option to consult the back matter, probably not called back matter for the ordinary user, but some indication that you can have additional text where the rules of grammar are explained. And in the case of the Northern Sotho copulative, it is, according to Dani and according to the best grammar book available, around 30 pages of densely compiled text to understand this in any detail. So you can understand that a decision tree through this complex path could make life much easier for the end user. And then you could simply have an additional button called something like Navigate Decision Tree. Once you click on that, you get to the little image at the bottom there. Oh, there are more people sitting on this side, so I suppose I have to show it on that side. And this is part of then the decision tree that you will see just now. We decided not to do a live demonstration, so this is frozen, as Uli has said, in terms of screen captures, and in terms of the weather outside, it might be a good idea to do it frozen because there's a slight correlation between the two at the moment. If you are in a text reception mode, you get limited amount of detail, but again, you have the option of searching on various combinations through entering information in a little search box. And I'll show you just now how this pans out. So if you, let's see, you can actually see the lines here. Open up the copulative decision tree. You have the option to choose between A and B, and depending on your choice, it opens up further. So you have, if you click on that one, you have 3 options from which you can choose. And again, if you click on the middle one, you again have 3 options from which you can choose. And so you can navigate through the tree. It gives you at the top there the actual path. And if you get to the 15 or 18 noun classes, you have the whole set of items on screen. So it provides the context, so you can see those that are not blue is the path that you have actually followed through the tree, and you get to the so-called leaves or the lexical items that you need to express the concept in Northern Sotho. I don't think there's a separate slide on that, but if you were to click on, say, that one, the rest of the tree, all the other stuff that is shown collapses, and you only see that part of the tree then on screen. Here's a slightly enlarged version of this, so you can easily see it gives you the classes and so on. Obviously, this requires that you have an understanding of Northern Sotho as language, how it works, and so on. So it is not for the person who knows nothing about the language. It provides at this stage very limited additional information, but you see there you have the little more, which is a standard convention on the web nowadays. So if you click on that, you could have lots of additional information, and it could also link to the back matter, to grammar, to text files, to images, and so on. I'll show some more of that just now. If you're in a text reception mode, you saw the little search box. If you put in the words or click on the words that you would like to search on, click search, and it then opens up the various options. So it's a reverse traversal of the tree. There you have the lexical items. It is a negative of the 16th class, of the 3rd person, etc., etc. So you get the full path through the tree to enable you to figure out what this actually means. We also have made provision for wildcards. So if you put in na, it gives you kenale and ha kenale, etc., etc., so that you could have, you don't need necessarily put in input the full phrase, but it gives you the various options and then all the options, and you can select which one is appropriate. If you're in the editor mode, therefore, when you're the lexicographer, it's quite easy to actually add information. So if you want to add a new node, you right-click on the current node, you can name the node, you can add various field information, you can, as you can see there, obviously update, you can add YouTube videos if you want to, if you have the ID, but you could also upload additional files. As I said, all the different file formats are supported. And you can also add any number of new nodes, 1 or 2 or 10 or whatever the case may be. And then, of course, you can also remove a node if you want to, and we have also implemented the option of moving nodes around in the system. If you find out that at some stage you have put a node in the wrong space, you can drag and drop it to another position. So it is actually quite easy to input new data. Currently, we have not yet been able to convince the system to import data from a spreadsheet, because for the simple reason it seems to be even more difficult to try and represent this complexity of grammar in a standard spreadsheet, and it's actually much easier just to click and paste, point and click and paste type of thing. So, computational architecture of the whole thing. It's a server-based application. We're using a relational database. The relational database currently is MySQL, and since MySQL is not humanly readable in a very easy format, we have XML as an interoperability standard, so whatever you input into the database can be shown as XML as well. If you look at so you have the SQL database there, you can export via XML to the user who wants to do the searching or the traversal of the graph. You have JSON objects which are visualized through, as we said here, SVG, scalable vector graphics tool, which represents the trees on screen. It's exactly the same tree that you have there for the input of the data. Right-click on it, you go through the visualization tool, obviously through JavaScript, Ajax, HTTP post, which puts the data back into the database. So it's a very easy system in terms of the whole structure. Of course, this is a standalone little application, so it can be implemented in any other dictionary, and it is also separate per word or per construction. And what we didn't say at the beginning, obviously, we will use this type of tool only in the case of seriously complex stuff. You don't need it to distinguish between table and chair, for instance, because these are quite obvious. Here you can see the XML representation. So by simply clicking on a little button in the edit mode, you can export this to XML. One article represents one document, and the tree structure is represented with all its options within the XML tree. So that little piece of XML there would give you this output if you attach the proper style sheet to it. Oh, something happened that shouldn't have happened. There it is. In terms of implementation, we could have used XML. The advantage is obviously that it's human readable and editable. However, if you look back at the previous little example, the XML might be humanly readable, but quite difficult to interpret. So human readability is a bit of an issue there. But the XML is required for interoperability, and so that obviously makes it very easy. Disadvantages, less efficient for searching. You've got restricted scalability. If you have really a large scale system, it becomes considerably slower. And it's not very easy to move stuff around if you just change your mind on where something should link. So we went for the database representation. Each entry contains the item data, the references to the parent and child nodes, the metadata that's required, and we use SQL queries to traverse the whole system. The advantages for using a standard MySQL database is fast searching based on primary keys. The word indexing is standard indexing based. Scalability is very easy. It's very easy to change the structure for inserting and deleting and moving things around. The disadvantages, of course, if you look at the MySQL database, there's no ways that you can understand anything that's actually in the database and how these things are linked to one another. You need complex queries for tree representations, and for interoperability, you need something in between. And I'm running out of time. So, future work, this is the last slide. We need to look at the interface to enter trees at any non-root mode. So how do you get a person to be able to start in the middle of the tree? Possibility to select relevant subtrees, etc. We have to explore this for other language phenomena, such as the kinship terms, the colored terms, and possibly data from other languages. We found out that the tree structure works very well for something which is fairly binary, as the examples that we have currently. But if you have slightly more complex structures, such as the kinship terms or color representations and so on, it becomes impossible to use simple tree structures, and you have to go to graph representations and so on. And then, of course, we need to do user testing, usability testing of all of this to see whether users can actually use this in any which way, and also see whether it is feasible to use this in other environments, for instance, for computer-aided language learning and similar types of applications. Thank you.
We have time for questions. Yes.
Thank you. I would like to ask about sequential element of decision tree. It was not clear to me. Does it come as a design? So you design, you know, in which sequence the tree will go, or actually are you able to infer the tree from this complex morphology? So which is the case?
Actually, I don't think I can answer the inference question in detail, because that is something which the linguists have to talk about. For the time being, we have produced these decision trees manually, so they are not generated from, say, feature bundles or something. I could imagine doing that, but in the general case, different types of trees with different shapes would come out from the complexity of the different features. So for the time being, what we do is start from a careful analysis of the linguistic phenomena. And as you saw, a quite natural sequencing is one where you would start for this very phenomenon with a semantic distinction on top and then add in the grammatical ones. But not necessarily this is the case for all the phenomena. Maybe Dani can say something about that.
Yeah, no, I think that is exactly what it is. The examples that you've seen are in fact also totally binary. You really have to go, it's either this one, and then that, but not as serious as said, not all structures will be binary in the end.
So I think the idea as such is convincing to present just the information you think the user wants to have in a task. But I think it's really hard for users to cope with such an interface. You said you don't make any user studies right now, but our user studies always say, show that users want to have to make quick and easy, and also log files show that users tend not to use extended search options and so on. So how do you want to cope with this problem that you often said the word easy, but it's not easy for the user to cope with such an interface, probably. And for example, users tend to skip between productive and receptive tasks. How do you want to cope with this problem? Or don't you think you might annoy some people if they always have to go between this big decision tree?
So, yes and no. If you consider the 3 times 15 cases of this particular example, and if you look at a grammar table, so to say, which would just have all the options sitting silently there and waiting for you to discover the right one, the user would not have to click his way through the table, but say the mental operation would be roughly the same. I agree that this kind of stepwise procedure is something which might annoy advanced users which say, I want to enter the thing basically at that level. And this is why we said that the next step would be one where you could really enter the tree not just from the start, but from any place in between, and then just get the relevant subdivisions which you might not be aware of in all detail in a given text production situation. That users change between production and the reception views is quite obvious, but that is something we haven't yet been able to address in a reasonable way, because many users are not even aware of the fact that they change. So that is something we still have to think about.
Okay.
Yeah. It is, of course, also possible to have on the so-called cognitive dictionary, where you give everybody everything, to have the search and the navigate options on one screen, so that the person can, by reading the whole article, at the end of the article have the option to do either the search or the navigate to get to the relevant information that he or she would like. So there it's then only right at the end where you have to make the distinction or the choice between the two information provision options.
Unfortunately, we have to stop, so thank you again.